Okay, so I'm going to start with something just super basic. So this is going to be our equation of a line all the time. So y equals mx plus b, where there's always going to be a number where m and b are, and x and y are just going to represent any point. So x and y would be a point. So if I wanted to plot a point, let's say I wanted the point 3, 5. Well, then that means that I'm going to go on the x3 and on the y5. So I go over 3 and up 5, okay? And I'm not going to make the points because that's just a simple explanation. So you're always going to have just x and y because it can represent any point we want on that line. And we'll do some examples of those. Now, m and b, we're going to have numbers in there, and there will always be a number that your instructor gives you. So m will always represent our slope. And I always told my students that m stands for mountains, so mountain slopes. And b is your y-intercept. And I told my students b represents for the beginning. So it's the beginning where you're going to start your line. So we always start with the y-intercept. So again, this is our slope. And this is our y-intercept. Emery's sounding like she's waking up, so I'm going to make this one quick really fast. Okay, so let's start by graphing an equation. So let's do y equals 1/2 x. Let's do minus 4. Okay, so if I have y equals 1/2 x minus 4, then my beginning, or my y-intercept, is at -4. So I'm going to go on the y, and it's called an intercept because if you think of like football, if somebody were throwing the football and then the other team intercepts it, then they're crossing the path and they're going to be touching the ball. So that's an interception, and in this case a y-intercept is where it's crossing the path of the y-axis. So it's hitting the y-axis, a y-intercept. If it were an x-intercept, it'd be crossing the x-axis. So it's like what team they're playing for. So I'm going to start my y-interception at -4. So I just went down 4. And now my slope is always going to be the rise over the run. So in this case, I'm going to go up 1 and over to the right 2. Because up is positive and right is positive. And see, we have a +1 and a +2. If it were a negative, then it'd be going this way. Now, I always made my students, every time I graphed a line, I'd show me, with your arms, tell me which way that this line would look. Now, if it's positive, your right arm should be in the air. So if I were to make this line, it would look like this. So I always tell them, dance with your arms and show me the line. So this way your right arm would be in the air because it's positive, because we're going to go up and over. And if it were negative, then I'd be going down and over, or I could say up and left. So my left arm would be in there. So this is a negative slope, and this is a positive slope. So if you're positive, you're choosing the right. And I taught Mormon, so that always worked to remind them with that too. So we started at -4, and I'm going to go positive, so I'm going to be going up and right. So up 1 over 2, up 1 over 2, and that's my line. Okay, and then let's try one more on this. Let's do y equals -3/4 x plus 1. I'm just going to graph it on this same one. So it has a negative slope, so if I were to think about what this line is going to look like, my left arm would be in the air. So the line would be going this way. So I'll be going up and left, or down and right. So that negative could either tell me to go left, or that negative can tell me to go down. But it's going to end up looking like this. So my y-intercept is at +1. So I'm going to start up 1. And then I always go down and over. So if it's negative, I always assume that means down, and I always go right. That's just a habit of mine. So this told me up 1, right 2, and now I'm going to go down 3, right 4. So down 1, 2, 3, over 1, 2, 3, 4. down, 1, 2, 3, over 1, 2, 3, 4. Now, two lines will always intersect if their slopes are different. So if their slopes are different, they're always going to intersect. Now, they could be really close to each other and they might not intersect forever, like way out of our picture that we have. But if they are not the same, they will intersect. So if slopes are not the same, they're going to intersect because they have different paths. And if you're going different like measures of amount going up and down or whatever, they'll end up crossing. But if you're going the exact same distance in every place, they're never going to cross. So then you're never going to get a point where they intersect. So that's why on the last one, the parallel, the slopes were the same. So again, if the slopes are different in any sort of way, even if they look similar, they will cross. And that, yeah, will always happen. Okay, I'm going to get Emery and then I'll make you another video.